Welcome back to The Explainer. So if you're part of the CIP polymer tech community, or honestly just someone who absolutely geeks out over precision, you're exactly where you need to be. Today we're taking color matching to a whole new level. We're completely transitioning away from those manual visual color checks and diving headfirst into a fully digital instrument-driven approach. Look, if you want to be a professional color matcher in today's industry, mastering a spectrophotometer isn't just an option anymore, it's an absolute requirement. So let's get started. Here's our roadmap for today. We're looking at 1. Why go digital? 2. Decoding color data. 3. The measurement process. 4. Fixing colors with data. And 5. Avoiding common mistakes. Let's dive right in. Section 1. Why go digital? Moving past the guesswork. Okay, if you work in production, you already know the ultimate nightmare scenario. A client looks at your batch and says, "Hey, the shade is a little off. You really need to maintain consistency." It's so frustrating, right? Because honestly, what looks absolutely perfect to your eye on a bright Tuesday morning might look like a total disaster to your client under their weird office fluorescence on Thursday afternoon. It's that painful universal headache every single professional color matcher has to deal with. Now think about the stark contrast between the old way of doing things and the new industry standard. Relying purely on your eyes, well, that's inherently subjective. But an instrument, it hands you exact, undeniable numbers. And in today's demanding market, getting your product accepted means you need both a great visual match and the hard data. You literally need the numbers to prove your eyes are right. Section 2, decoding color data. Let's understand the machine's language. So what exactly is a spectrophotometer anyway? Well, think of it simply as a highly precise digital version of your own eye. Basically, a light source hits your physical sample, the device measures the light that bounces back, and then, here's the magic, it converts that light into concrete data. Specifically, it spits out L star, A star, and B star values, plus a really important metric called delta E. Let's break down what this LAB output actually means. Because remember, the machine just gives you numbers. Interpreting them is totally on you. So L stands for lightness. A high L value means light. A low L means it's dark. Simple enough, right? Then we have A, which tracks the red and green spectrum. Positive A is red, negative A is green. And finally, B handles the yellow and blue spectrum. Positive B is yellow and negative B is blue. You can think of it like a 3D map for your color. Now, alongside L, A, and B, the device hands you a completely crucial metric, delta E. Delta E basically indicates the total difference between your perfect, target, standard color and the actual physical sample you just made. It is absolutely the core metric you need to know to see exactly how close you are to nailing that target. And you know, the industry standards for delta E are incredibly strict. If your score is under 0.5, your match is considered excellent. If it falls between 0.5 and 1.0, it's acceptable. But the second that number creeps over 1.0, you are at serious risk of getting rejected. This is the exact scale your clients use to judge your work, no exceptions. But here's a massive warning, and you really need to hear this. The same delta E score does not mean the same visual appearance. Seriously, let's say you hit a delta E of 1.0. In one batch, that 1.0 might just be because the sample is slightly lighter than your standard. But in another batch, that exact same 1.0 score could mean the undertone is completely, totally wrong. This is exactly why doing a physical visual check is still completely compulsory. The machine is an amazing tool, sure, but it doesn't replace your eyes. Moving on to Section 3, the measurement process. Getting accurate readings. You know the saying, garbage in, garbage out? Well, we have to feed the machine good info. And we do that by following 4 strict steps. Step 1, make sure your sample is flawlessly clean. Literally no dust, no scratches. Step 2, fix your background. Depending on your standard, lock in a consistent white, black, or gray background. Step 3, measure the exact same spot multiple times. And Step 4, take the average of all those values. Please never, ever make a major production decision based on just a single reading. To get that ultimate balance in our industry, you really need both tools working together. The machine, it's going to pinpoint the exact direction of your error and give you the math. But only your human eye can judge the gloss, the surface texture, and the actual real-world appearance. Nailing that perfect match is all about combining the machine's cold precision with your own natural perception. Section 4, fixing colors with data, actionable corrections. Consider this data framework your ultimate cheat sheet. So, if your instrument says your sample is too dark, meaning your L value is low, your action is super simple. Add white. If the sample reads too green, so a negative A value, you add red or yellow. And if it's reading too yellowish, showing a positive B value, you just add blue. We're talking about making hard data-based corrections here and literally taking all the guesswork right out of the equation. Which brings us to Section 5, avoiding common mistakes. Don't let the machine fail you. All right, let's talk about the 5 fastest ways to totally ruin your digital readings. 1. Measuring dirty samples. 2. Completely ignoring gloss differences, which totally throws off how the light reflects. 3. Trusting a single reading instead of taking an average. 4. Only staring at the total delta E while ignoring the specific L, A, and B values. And 5. Skipping the regular calibration of your machine. Listen, a highly precise machine will only work correctly if the operator actually respects the process, right? I really want to leave you with this vital industry tip. A spectrophotometer is fantastic. It will tell you exactly what is wrong, but your hands-on experience, that's what tells you how to actually fix it. These digital tools aren't here to replace human color matchers at all. They're here to elevate us, giving our intuition a solid framework of undeniable data. So we've covered the basics of the spectrophotometer, the practical use of L, A, B values, what delta E actually means, the right measurement method, and how to make data-driven corrections. But that begs the question, are you ready to apply all of this to real-world industrial cases? In Day 16, we're going to dive deep into advanced lab and production color correction techniques. If you found this explainer useful, be sure to hit like, subscribe to CIPPAT Polymer Tech, and drop a comment saying Day 16 ready down below. Because as we step into this wild future dominated by AI and automation, you really have to ask yourself, are you going to let the machines replace your judgment? Or will you master the data to become completely irreplaceable? Keep your data precise, and we'll catch you in the next one.
So friends, today we learned that a spectrophotometer is not just a machine, it is a powerful tool for color matching and quality control. We also understood that the delta E value tells us the difference between the standard color and the sample color, while lab values show the exact direction of the difference. They help understand whether the color is a lighter or darker. Okay? Move toward red or green or toward yellow or blue. Okay, bro? In the plastic industry, depending only on your eye is not enough because color appearance can change with lighting conditions, background, and even from one observer to another. That is why spectrophotometer and lab data provide specific and consistent result. Once you learn how to read delta E and lab value correctly, color correction, set approval, and solving customer complaint become much easier. Let me know in the comment what is the maximum acceptable delta E value in your company. Do you ask lab value for color correction? If you want to learn plastic color matching, Masterbatch formulation, pigment selection, color correction and quality control step by step, make sure to subscribe to the channel and turn on the notification bell. See you in the next video with another practical industry topic. Thank you for watching and keep matching color with confidence. Okay, thank you.